What if your computer could actually understand you and complete your tasks without you even knowing it? Spoiler alert, clicking and typing is about to become ancient history, and maybe it's time to say rest in peace to Windows, Mac, and Linux because we are entering the era of LLMOS, and most people have no idea this shift is already happening. Over the past few weeks, I've been researching this revolutionary shift to LLM operating systems, and I discovered the key piece most people are missing. The integration with LLMOps or large language model operations could create a more solid infrastructure that lets AI safely take control of your computer instead of just being a cool demo. If you've never heard of this stuff before, today I'm going to share my weeks of deep research with some pretty surprising findings so you can decide if it's safe to adopt this shift to LLM-based OS sooner rather than later. So let's go backwards. Even though the concept of generative models acting as the main operating system has been around for a while, one of the formal public discussions of it happened at the Y Combinator startup school event. There, Andrej Karpathy introduced the concept of Software 3.0, which I fully explained in a previous video. But during his presentation, Karpathy explained that instead of thinking of LLMs as these separate entities to do tasks, we can think of them as an ecosystem, such as an operating system, for example, like a CPU, where the context windows act as the memory, prompts become the programs, tool integration acts as system calls, and multimodal capabilities act as input-output or I/O devices. And just like you would talk to your operating system directly through your OS terminal with code, you can now directly talk to your LLM with natural language. The mode has changed, but the underlying concept has remained the same. Now, let me zoom out of Karpathy's talk and give you a real-life example with this AIOS paper from a few months ago. It introduces a novel architecture for LLM-based AI agent operating system. In this architecture, the AIOS kernel provides fundamental services, for example, scheduling, context management, memory management, storage management, and access control for runtime agents. AIOS also includes a software development kit, which is a comprehensive pack of APIs designed for using functionalities provided by the AIOS kernel. So, essentially, this operating system provides services such as disk access and software execution to the language models as agents. This way, any agent under any agentic framework like LangChain or AutoGen can use the core LLM which acts as the operating system and perform any task. To simplify it a bit more, instead of predefined commands, in the LLM-OS systems, an AI model interprets and executes commands and generates the functionalities needed from an operating system without the need to constant manual input. So you can speak or type instructions in your own language, and the LLM interprets these instructions to carry out tasks and manage applications you used to do manually, for example, installing an app or booking a service. Let's see how this works with this image of AIOS. As you can see, this operating system has 3 layers of application, kernel, and hardware. Application layer facilitates the design and development of agent applications by providing interfaces for requesting system resources within AIOS. The kernel layer manages core functionalities and resources to serve agent applications. It has 2 components: the traditional OS kernel for non-LLM computing tasks such as memory manager and file system, and an innovative AI-based OS kernel for LLM-based tasks such as agent and tool management, context window, and memory management. In this one, each of LLM instances as cores act like CPU cores. For example, a dedicated processing unit to manage various LLM endpoints. I will leave the link to this paper so you can read more details about how this concept of LLM as an operating system works with the agent examples they have provided. There are other LLM-based systems, such as Baby AGI and MemGPT, which stands for Memory GPT, which are not fully fledged operating systems, but demonstrate complex functionalities that can be used for it. I won't get into their details in this video. But for now, let's talk about warmwindOS, which is perhaps the closest we can get to the idea of an AI operating system from human perspective. I mean, the way we personally click on buttons, fill in forms, and interact with our files. So warmwindOS is an LLM-based operating system, but not a fully fledged one, because it runs on a customized Linux distribution and is specifically designed for entire workflows from start to finish, just as you would do, but much faster. It has this visual representation to it that mimics how humans go about their daily tasks with a keyboard and a mouse, much like an agent. But unlike other agentic systems which require MCP servers to access tools, Warmwind comes without any integrated API because they believe using visual generative AI models work better for unstructured environments. And just by seeing your workspace, it can decide how to interact with tools, which gives the user visual feedback. And it still can interact with all sorts of applications, cloud-based systems and apps, managing everything about your emails and even your social media. The cool thing about it is that it is scalable and you can set up multiple workflows in parallel. Keep in mind that this operating system is not fully publicly available yet, and there are some skeptics saying that giving full control of your machine, including your keyboard, could pose security issues. This is where the whole concept of LLMOps that I talked about earlier come into play. If you are not familiar with this, large language model operations is the next evolutionary step of the MLOps or machine learning operations, which is already an established series of methods and workflows for managing machine learning models. Unlike machine learning models that required constant human intervention to set up and use the predictions, generative AI models could actually perform tasks on their own, so they require a different set of pipelines and management system. For example, a traditional machine learning operation includes data pipeline management, model training from scratch, model evaluation often with traditional metrics such as accuracy and area under the curve or AUC, as well as model deployment and monitoring. This whole system uses deterministic algorithms and pipelines, so there is a high degree of control on the outcomes. On the other hand, building large language models from scratch is hugely expensive and processor intensive. So LLMOps often use the already available foundation models and then use techniques such as fine-tuning and knowledge transfer, such as distillation and transfer learning, to curate generative models for specific tasks. Not only that, evaluating LLMs has its own huge wonder world, from different benchmarks such as L-Uter evaluation scheme set to new evaluation dimensions for AI safety and hallucination, each of them with their own submetrics and techniques. So these additional categories are also handled by LLMOps before LLM can even function as a reliable operating system. I'm not even attempting to discuss other issues such as model inference and training and computational efficiency here. It's a vast topic. If you'd like me to discuss these topics, let me know. But as you can see, LLMOps is not just a convenient partner, but a very necessary infrastructure for LLM operating systems. These are the hidden operations under all those fancy automations and cool agentic workflows you see when LLM acts as operating systems. But if you want to know how this combination with the concept of software 3.0 helps the process of agent engineering, then check out this more detailed video.